Whilst the Z80 microprocessor is one of the most successful 8-bit microprocessors ever, shall we say, the Z280, which followed after it, was perhaps one of the least successful. There's also a Z380 as well. If you've been looking at my channel before, you may well recognise some of these processors in front of us here, because we've already covered some of these, and the Z280 seems a logical one to do next. We have the 68,000 microprocessor. We have the three sorts of Z80. There's the straight Z80, the Z80A, which is a faster version. It's 2 meg, 4 meg, and the 6 meg for the Z80B. This is one I haven't covered, but I might be tempted to try at some point, and that's the 8080, which was one of the, you could almost call it like a predecessor to the Z80, because the code is, you can run the code on here on Z80, but Z80 has more instructions. You can't necessarily run what was written on the Z80 on the 8080, but you required these three chips. You had a system controller as well, which is an 8228 and an 8224, which was the clock generator. You had to use all three of those, but the Z80 it's all in one. But you need a separate clock for the Z80, but you didn't need a chip for it. Then we come to the 6502. We did a video on that showing how to use one of those, and two versions. There's a beg your pardon, 6809 and a 68B09. This is a Motorola device. This one we covered as well, which was the unsuccessful Philips 84C00 and 84. Which one was this one? This is the 8401, which is the non-CMOS version with the piggyback socket on the back. Another one that was not a success. May well do a video on the Z8000. This is a Z8001, which is one of the versions, which will be quite interesting. But here we have the Z280 itself. Very similar to the Z80 in many ways. The Z280 is quite a fun thing to try and use if you fancy trying something a little different. So if you like the Z80, then you may well find the 280 would be fun to actually make a project using. The only thing I don't like is the PLCC package, which unfortunately means that you have to have obviously a corresponding socket, and I found rather difficult to wire up myself. As you can see here, this is typically what the underside of the socket looks like, and you can see it's not that easy. You know, have a bit of a shaky hand and you join up two of the connections together and all this. It's not easy, but it can be done. Back to the actual programming itself. There are two methods. There's the Z bus and there's the standard Z80 mode. For the test, which I'll be showing, our little experiment, I'm just using the standard Z80 code, but the Z bus is an alternative to that. You can run either of those in a Z280. The Z380 was like a bigger brother, but once again I don't think it was a terribly successful processor at all. But one thing might be of interest to experimenters with the Z280 is the fact it actually has some extra bits on it that the Z80 doesn't have, and that's it actually has a UART on it, which means you can do serial comms. It also has three 16-bit counter timers you can use in, which is useful, and it also has its own clock generator on there, so that's particularly useful as well. And we're ignoring of course the 4 DMA channels. It depends really how much you want to do with your experimentation. I mean, what I try to do, as I'm sure anybody who's seen my previous videos will remember, is with the 68,000 I've tried to show what the absolute minimum you can do to actually make the thing work. Now there are other Z280 projects, shall we say, online, but I think all of the other ones are simply showing it in a situation where you have a pre-made board, or you're going to run a specialist operating system in it. This, we're doing exactly the same thing we did here as we did with the 68,000, the Motorola one. We're going to show exactly what the absolute minimum you can do to actually make it work. But unlike 68,000, you don't need two EEPROMs to make one of these work. You just need the one, just like a Z80, and that is using it in the standard Z80 mode. Obviously the Z280 is a complicated beast, and there are a lot of things you can do with it, but it's probably best, like my little philosophy, you start at the bottom and you work forwards with it. You start off by using the minimum amount so you can actually make the thing work, and then you can start adding extra facilities or using some of the other parts that are in it once you have the basics working, and that's how we'll go ahead. You'll notice the way we've actually constructed it on this occasion is exactly the same as we've done with all the other projects that I've done on this channel. We put it on a piece of veroboard and we line up the ICs with the power rails to either side and start off by doing an absolute minimum to make the thing work. And here we have the populated board. This is showing the bare minimum of components you actually need to make one of these Z280s actually work. There's a latch here because the multiplex data and address lines, so there's just a 20 pin chip here. Then we have an LS14, which is just simply used actually for the reset circuit. That's all we're using it for at the moment. And there's a 139, which is an address and memory decoder, and a 32, which is used as just an OR gate. I think one of those gates is actually used. This is the classic DL1414 display which I'm using here, which we're just simply going to use just to show the thing working. There is actually another IC socket here which is for a real-time clock, because my project I'm going to use this for needs a real-time clock, so that's going to go in there. That isn't needed at the moment. Likewise, the I/O ports all go through the Z280. We don't have that in because once again we don't need that. And of course there is no RAM either. This is a 2.4576 megahertz crystal, which means that the dividing down for the serial port will work fine. Aside from that, there's not a lot else other than the test program here in the ROM. On the other side, of course, we have the wiring, which is as complicated as it normally is. But I find these particularly difficult to wire, and I don't think there can be many people who find it easy. If you look here, here's a close-up and you can see just how complex some of that wiring is. And obviously you have to make sure you make connections to your pins and you don't short out other things at the same time. As per usual, I build my circuits using a net list here, which is a core wiring list. There's an awful lot of it. You probably can't see any of it here. But what I'm going to do is I'm going to put these up at the end, which you can take screen grabs of. I'll do it in 2 pieces in case you want to follow it. This has all the wiring connections between each pin and the signal names as well. It's quite easy to follow. And if you look, what I'm also going to include is a sheet showing my checklist on the bottom of the socket. I didn't want to make any mistakes on that 68 pin socket, and so you can go through that again. I'll put that up at the end, and you can, if anybody actually wants to make it, it's a practical proposition if you follow it carefully. And then, as I said, you can always expand it and add more facilities at a later date when you actually have the basics working. This is another sheet of paper I shall put up right at the end for those interested in making the device. And this is actually showing the pins that we're not using, because of course there are a lot of pins that we will not be using in the basic version, and so this one lists and helps clear up the fact that if you find a pin without a wire in it, is it supposed to be without a wire, and that's where this is useful. Lastly, here is what we say, a very skeleton circuit diagram. As I explained, all my wiring I do up to the sheet. The circuit diagram I've never actually sat down and worked it out. This is pinched from another circuit using a Z280, and this actually shows the rough idea of what we'll be using to make the thing work. Once again, this one I'll put up at the end in case anybody wants to have a go at making it themselves. And here we have it. This is the well, it's a bit of an anticlimax, isn't it, after all that? The board is now made. I've connected up 2 power leads to it. All we've done is done the usual sort of thing in the program, is simply output to the display the sort of a couple of numbers so that we can actually see that the thing is working. If I turn it on, click, it works. A little dull, I know. You would imagine do something more exciting, but there's only a couple of lines to the program. Z280, there we go. So the thing is working. If we hold the reset button down, we switch off the power, obviously, turn it on, release the reset, and up she comes. Now I'm pointing this out because it's quite interesting that when I was actually making this board, it didn't always start when you did the put the power on, which is strange. I thought what it should do, because there's the capacitors on the reset line. And also another really weird thing was the fact it didn't always come up with Z280. It sometimes came up with Z80 or just 80, and I thought there's something really strange going on around here. Took quite a bit of sorting out, working out there were no dry joints or anything, and what it actually turned out to be was the crystal was running at an overtone and it was running too fast and the display couldn't keep up. So what I did was added, that's the extra capacitors you can see here. I added an extra capacitor to load the crystal a bit, and it brought the frequency down, and hey presto, it now works properly. So it's worth bearing that in mind. Although strictly speaking it's supposed to have 15 picofarad and 15 picofarad to the ground from both legs of the crystal, this one now has about 25 on one of the legs and it works fine. So there we go. What I might do is, after this, is wire it up with the RAM at 8255 and with the real-time clock, and I might do a second video just showing the real-time clock working in it and the 8255. But say all the bits and pieces are up at the end if you actually want to try making it. The object, the exercise is to actually make the thing work. You know, we can all talk about what we might make it do at a later date, but I think the most important thing, as you can see here, is actually to make the thing work. I'll put up the pictures for a couple of seconds each so you can take screenshots of them if you wish. Otherwise, thanks for watching.